Figure 6.9 craps.java. In this example, we're going to write a program that simulates the dice game craps, and the basic rules of the game are as follows. When you first roll your two dice, if the total of the two dice is either 2, 3, or 12, you lose. If the total of the two dice is 7 or 11, you win. For any other value, that's known as your point, and this is actually where the expression make your point comes from. The way you make your point is by, on a subsequent roll, rolling the point value before you roll a 7. So if you roll your point value on a subsequent roll, you win. If you roll 7 on a subsequent roll after the first, you lose. Now, before we get into the code here, I'm actually going to just go ahead and run the program so that you can see what happens. It's a text-based output program, and basically it just runs one full game and then the program terminates. So here I happen to have rolled a 6 and a 1, totaling 7, and therefore I won on my first roll. Good start. If I run it again, in this case I happen to have rolled a 3 on my first roll, so I lost right away. Let's run it again. Wow, I'm doing pretty well so far. I rolled another 7. Here we go. So in this case, we rolled a 2 and a 2 for a total of 4, and that is not one of the values on which you win or lose. So our point is 4, and now we need to roll a 4 before we roll a 7. So we rolled again and we got 5, then we rolled again and we got a total of 4, so we won in this case. I am winning an awful lot here. Okay, here we go with a loss. In this case, we rolled a 1 and a 5 for a point of 6. Then we rolled an 8, so we continue rolling until we roll either a 7 or our point, and in this case we rolled a 7, and therefore we lost the game. So you can get the basics of how the game works by looking at several program executions here. Let's go back over to our code where we've defined a class called craps, and we have a second file, a craps test.java file, in which we will create an object of this class and execute its play method to play one game of craps. Now you'll notice a new import declaration up here above the class for the java.util package's random class. The random class is used to produce what we call pseudo-random numbers, and it can actually produce integers and floating point numbers and even Gaussian values if you had a need to do random numbers for bell curves, for example. In our case, we'll use it just to produce integer values that represent the sides of a six-sided die. Now we go ahead as one of our private instance variables of class craps and create a random variable called random numbers, and we haven't done this before. Notice we're initializing this reference variable immediately when it's declared. You are allowed to do this in Java. What's going to happen is at the time that the craps class's constructor gets called, it will execute the code that's actually going to initialize the random numbers variable. But this will create a new object of class random that we can then use to produce random numbers. And by the way, if you scan through the code quickly, you'll see that I did not provide any constructors. I have a roll dice method at the bottom here, and I've got a play method, but I did not define a constructor. So in this case, when the default constructor gets called is when this new operation would actually be performed. Now we have another new feature in this example. On line 11 here, we declare a special type called an enumeration, which is declared with the enum keyword in Java. An enumeration can be declared as a nested type within a class, which is what we're doing here. So the status type is privately used only within class craps. But it is a type name that we can then use to declare variables, and the interesting thing about an enum type is that the variable values are only those that are specified in the curly braces of this enumeration's definition. So in this case, what we're doing is creating a new type called status, which we'll use to represent the status of our game, and we have 3 constants that we've defined: continue, won, and lost, that represent whether we need to continue rolling the dice, whether we've won, or whether we've lost the game. Now, the only values we can assign to a status variable are these 3 values, otherwise we'll get compiler errors. Underneath the hood, these values are actually integer values, but interestingly, you cannot compare these constants with integer values. You can only use the constant names that we're declaring here, and by default, the values of these will be 0, 1, and 2, respectively. So this is one way to define named constants in your code. The key benefit of it, again, is that you can only assign these three values to a variable of type status, and we'll show you how to use that momentarily. Another way to define constants, which we discussed briefly already, is the concept of a final static variable. So when you declare a variable final, you're indicating that it's not going to change. When you declare it static, remember that means that exactly one copy of that exists, no matter how many objects of the class you ever create. And in this case, we're creating a final static integer called Snake Eyes, which is a common name in the craps game for the value 2. And then we've defined some other common names for certain values. We have tray to represent 3, the word 7 in this case to represent 7, Yo11 to represent 11, and boxcars to represent 12. So if you've been to a casino, you might hear people call out Snake Eyes, Tray, Yo11, or boxcars. You probably will hear them say 7 as well, but the main reason we have this variable, or this constant rather, is so that we can use named constants throughout our code for readability rather than just hard-coded integer literal values. So when we start up our program with the crapstest.java, in fact, let's look at that quickly, you'll see that the first thing we do is create an object of class craps, and then we tell the craps object called game to invoke the play method, and that's going to play one game of craps. So let's take a look at this method. At line 21, you see the play method, which returns nothing, and it's public so that we can call it from another class. And inside the method, we have a local variable called myPoint of type int, which we initialize to 0, but eventually this could be assigned a value which represents what we need to roll to win the game. And here at line 24, you see that we're using our new enumerated type status to declare a variable called gameStatus, and we're going to assign to this variable one of the constants from the status enumeration so that we can keep track of the game status at all times. At line 26, we invoke the roll dice method to calculate the first sum of the dice, and let's jump immediately down to that method so we can see how we've defined it. In roll dice, we're going to have it return an integer representing the sum of the dice, and lines 71 and 72 are going to calculate two random values in the range from 1 to 6. So let's talk about our expressions here. First, let's look at this part of the expression where we use our random numbers random object and its next int method in particular to produce a random number in the range from 0 through 5. So the number you specify as an argument here is the total number of values that it's going to produce. 0 through 5 are 6 different values, and then separately we're adding 1 to the value produced so that we always get a number from 1 to 6. So this is how you can, if you will, shift the random number range to start at the value 1 and then to continue from 1 up to 6. And we do that again here for die 2 as well. So we pick two randomly generated numbers. We add the two values together, display a line of text telling us what the two die values were and what the sum of the dice was. And you can see the die 1, die 2, and sum values being output. And then finally we return the sum of the dice. Now we come back up here to our play method and we take our sum of the dice and we use a switch statement to determine if the player won, lost, or needs to continue rolling. So initially here we test two different cases at lines 31 and 32. If the sum of the dice is either 7 or 11, then we're going to set game status to the status.1 constant. So the way you use one of the constants in an enumeration is basically as if it's a static variable of a class. The enumerated type name, a dot, and then the constant name. So here we're saying that the player won the game, and we'll break out of the switch statement to jump down to line 48. On the other hand, if the player rolled 2, 3 or 12, then we're going to set game status to status.lost and terminate the switch. And then finally, for all other values, we're going to set the game status to status.continue. We're going to store the sum of the dice in myPoint, so we keep a record of what the point is, and we'll determine later on if we've made the point. And then we display what that point value is. And of course, this break statement is not necessary because we're already at the end of the switch, but we include it for symmetry with the other cases. Now, once we've passed the first roll of the dice, we have a little while loop here at lines 48 through 58, which deals with the case where we need to continue rolling. So only if the game status is equal to status.continue can we continue rolling. If we are indeed required to roll again, we'll invoke roll dice and store the result in sum of dice. And then we'll check to see if the sum of the dice is equal to the point. If it is, we've now won the game. So we set game status to status.1. Otherwise, if the sum of the dice was 7, we set game status to lost. And otherwise, we simply leave game status alone, which means it's still going to be status.continue in that case. Assuming that we've either won or lost, we'll get out of this loop and we'll go to our little if-else statement at the end of the play method, which will test to see if the game status is equal to 1, in which case we'll print player wins. Otherwise, it has to be equal to lost, and we'll print player loses. The reason it has to be either won or lost is because if it were status.continue, we'd still be back up in this loop here. So one of the things that's nice about this example is it shows many of the different control capabilities of Java. We've got methods, we've got control statements like the switch statement, the while statement, a nested if-else statement, and another if-else statement here as well. So you see a lot of the different syntax of Java in this example. And then separately, the other nice feature is the introduction of the concept of an enumerated type, which allows you to define a set of named constants, which you can use throughout your code, and you can use those in switch statements as well. So those are valid for use as cases in switch statements. And again, the key thing about any enumerated type is that when you declare a variable of that enumerated type, you actually can only assign to it the specific constants that you've placed in the enumeration definition. Now there's one other thing I want to show you in this example, and I'm going to go back to the command prompt for that purpose. I want to do a directory listing to show you the files that are in this folder. Now we have the craps.java file and the crapstest.java file, and you've already seen in prior examples that when you compile each individual class, it gets its own .class file. So for example, here's the craps.class file and here's the crapstest.class file. But the interesting piece is this one right here, which is actually a separate .class file for our status enumeration, which is a nested type within the craps class. So this is how Java indicates that the class craps has a nested type called status, and it gives it its own individual .class file. So actually, every new type you create in Java, whether it be a class, an enumeration, or as we'll eventually see in the next video course, an interface, gets its own .class file, and each of these is individually loaded at runtime by the Java runtime environment.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.